Hello there. We're looking at one of my favourite things today, arrays. But first, here's 3 get ready questions. Pause the video and have a go. How did you get on with those? 5 counters in the first one. 2 lots of 5, so 10 counters in the next one. And then which representation shows 6? Did you get these ones? Great start to today's lesson, if you did. Here we have an array of tarts. How many tarts are there altogether? Well, we can see 3 in the top row and 3 in the bottom row, so 6 altogether. Or we could look at the columns. 2 in the first column, 2 in the second column, and 2 in the third column. Again, 6 altogether. How many cakes? 2 in the first row, 2 in the second, 2 in the third, 2 in the fourth, and 2 in the fifth. These are very tasty arrays, aren't they? Or what about the columns? Yes, 5 in each column. So, what is an array? Well, arrays have rows which run from left to right. For it to be an array, it has to have the same amount of objects in each row. We have 2 rows here. We can represent this with a repeated addition, 6 plus 6, because we have 6 apples plus 6 apples, which is equal to 12 apples altogether. We could also represent it as a multiplication. 2 times 6, or 2 groups of 6, is equal to 12. Arrays also have columns, which run up and down. This array has 6 columns. We could represent this as a repeated addition too. 2 plus 2 plus 2 plus 2 plus 2 plus 2. Or we could represent it as a multiplication. 6 groups of 2 apples is equal to 12 apples. What do you see here? Pause the video to have a think. Yes, I can see 1 row of 4, 2 rows of 4. We could represent this as 4 plus 4, which is equal to 8, or 2 groups of 4, which is equal to 8. Yes, don't forget the columns. 2 pairs in each column. 2 plus 2 plus 2 plus 2 is equal to 8, or 4 times 2, 4 groups of 2. Which is equal to 8. To be an array, we have to have the same amount of objects in each row and in each column. So when we add in an extra pair, we no longer have an array. Oh, hello Tiny. Tiny says you can't make an array because 9 is an odd number. Oh, is that right, Tiny? Pause the video and have a think. Maybe get yourself 9 objects, counters or cubes or something small, and see if you can make an array. Remember, we have to have the same number of objects in each row and the same number of objects in each column. Pause the video and have a go. How did you get on? Let me just move these pairs around. 3 pairs in each row and 3 pairs in each column. I've got the same amount in each row and I've got the same amount in each column. 3 pairs plus 3 pairs plus 3 pairs is equal to 9 pairs. Or 3 times 3. 3 groups of 3 is equal to 9. I can do it. It's your turn now. Have a go at questions 1 to 4 on the worksheet And remember to look at the little symbols. You might need some materials to move around. Have fun. Have a go at drawing an array to represent 5 times 3. Pause the video to have a go. How did you do? Did your array look something like this? With 5 in each row and 3 in each column? Or did it look something like this? With 3 in each row and 5 in each column? Both are brilliant arrays. If you had 16 counters, maybe you've got 16 counters now, or 16 small objects. How many different arrays can you build with them? Pause the video to have a think. Did you start with 1 row in your array? 1 row of 16? And we know that this could be 1 column, couldn't it? 1 column of 16. And we can represent this with 1 times 16, or 16 times 1. So what about 2 rows? Oh yes, that works. 2 rows of 8. And we know we can turn this round and have 8 rows of 2. What about 3 in each row? Oh no, it doesn't work. There's 1 counter left over. But 4 rows does work. 4 rows of 4. I've spotted a pattern with our arrays. Have you spotted it too? Have you noticed that if we half 16, then we get 8, and if we double 1, we get 2. So 16 multiplied by 1 becomes 8 multiplied by 2. This is how it looks with our counters. Here's our row of 16, and if we half the row and double the amount of rows from 1 to 2, we now have 8 in each row and 2 rows. And it works again. If we half 8, it becomes 4, and if we double 2, then again we get 4. Let's see how this looks. So we half our array, and then we double the number of rows. Yes, 4 times 4, all using 16 counters. I wonder if this always works for every array. Maybe you could investigate that. This is the final array we'll look at today, but it's a really interesting one. Dora says, I can see 2 groups of 6, or 2 times 6. And Amir says, yes, I can see 6 times 2, or 6 groups of 2. Rosie says, I can see 3 groups of 4, and 4 groups of 3. Whitney says, I see 1 12, and 12 ones. Can you see all of those equal groups in this one array? Pause the video to have a think. Ah yes. Here's 2 groups of 6. And here's 6 groups of 2. So what about 3 groups of 4? Oh yes, 3 groups of 4. And 4 groups of 3? Oh yes, brilliant, Rosie. And then of course, 1 set of 12 and 12 ones. Did you spot all those too? Are there any other arrays that this works with? I hope you have fun investigating. And now it's your turn to have a go at the rest of the questions on the worksheet.